Hello and welcome to the Hec-Ras tutorial. So first we have to open Hec-Ras. This is the software. And first what we're going to do is under Options, Program Setup, Default Project Folder. We choose our working folder, which is Task 1. You created it before. And then we press OK. Now we create a new project under File, New Project. We name it Base T1 and we choose our default project folder. Now there is a small thing, we have to choose Base T1 because otherwise it creates an error. So the name is Base T1 and the project file is, the file name is Base T1, and then we click OK. And it's asking us if we want to change the SE units. We say OK, and now the next step is we have to change this units. We go to Options, Unit System, and then I have already System International Metric System. You have to check this one, and then you can say as default for new projects. Then next time you can't work with US system and you're automatically in System International in the metric system. So now we are going to the geometry where we can enter, for example, the cross sections. We press the geometric data window. First we create a new geometric data. So we name it Base Model Task 1. And you see the file name is still Base T1 and it's under Task 1. Okay. Then we are creating our river reach. So we take here are the tools and here are the editors, and we take river reach. We left click mouse on top of the screen, go down, and then we double click the screen. Then it asks us what's the name. We say main river and it's reach M1. We click OK. Now we have created our main river. Then we go to cross sections where we can create our cross sections, and now a new window pops up with the cross sections. Then we have to add a cross section. Options, add a new cross section, and we will start with the highest number. We name 7. So this is high number is upstream, low number downstream. Then we open our Excel file. And here we have our task number 1, and now we copy the cross section for cross section number 7. When you paste it, you have to mark the cells where you insert, and then you can insert it. Then if you press apply data, the print of the cross section shows up. Then what we can enter is downstream reach length. So we have here 50, like we said before. Each cross section is 50 meters long. And here we have our roughness value 0.035. So 0.035. And our left bank here is at 4 and the right bank is at 11. Now we apply the data. That's fine. So you have these 3 values here because you have left channel bank, right channel bank, and the main channel. And then you can split the Manning's value for the left river bank, right river bank, and the main channel. And the left bank is this red dot at 4 and the other one at 11. So we exit it. And then we have created our first cross section, which you can here see at 0.7. File, save geometric data. Now you have to do it for 6 other cross sections. I show you some tricks. So here what we have, if you look to the cross sections, they all have same distribution. So each is 50 meters away from the others. You see it by this number 50, 100, 150, 200, 250, 300. And then each cross section is 5 centimeters lower as the cross sections before, and all shape is the same. So what we can do now is options, add a new options, copy current cross section. So we copy it to station 6. Then we just go to options, adjust elevation minus 0.05. Okay, apply data. Options, copy current cross sections 5, options, adjust elevation minus 0.05. Apply data, options, copy current cross section 4, options, adjust elevation 0.05. Okay, apply data. Now I check it, so it's 35. If we go to Excel, it's 435. Okay, didn't do any mistake. Options, copy current cross section 3, options, adjust elevation minus 0.05, options, copy current cross sections 2, options, adjust elevation minus 0.05, apply data, options, copy current cross section 1, options, adjust elevation minus 0.05. Okay, apply data, exit cross section, file, save geometric data. So I back check it, river station 1, and we here at station 1. Perfect. So 20 is the end here, 20 is the end there. Perfect. So I close this. Now we can see this is our stream 7, 6, 5, 4, 3, 2, 1, and the main stream. And now we see our cross sections. So we can close our geometric data window, exit geometric data. So now we have to do we have to edit our steady flow data, because we have a steady flow of 5 cubic meters here. So here we go. This is our steady flow data chart. First we go to File, New Flow Data, and so we say steady 5 for steady flow 5. It's really important later, if you have a lot of different flow data, you have to know with the title and with the description here what you have. Okay. Here we can say the flow change location is cross section 7, so at upstream, and then we want to have 5 cubic meters. Next thing is we have to set the boundary conditions. So we have different, we can either set a boundary for all profiles or boundary for each profile at a time. We want to set it for all profiles the same, so we can use a known water surface at each profile. So, but we don't have it. We have a slope here. We can say critical depth. Then it's just calculating for each profile the critical depth. And no extra information is needed. So then there's normal depth, what we will use here, with a slope of 0.001. So 0.1% of water slope there. And the last thing what you can use is the rating curve. So if you know the elevation versus flow, for example, big rivers like the River Elbe, they have it, then you can use this one. Then we press OK. File, save flow data. So we set the boundary, we set the inflow. OK, then file, exit flow data. And now we have to run it. Therefore, we have to create a plan what it should do. So perform a steady flow simulation. File, new plan, steady 5. We have to do short identifier. We call it here run1, so R1. So our name now is steady 5. We have the short ID. Then we can choose our geometric file model. So it's base model task 1, and the steady flow file, it's steady 5. Here we can choose our subcritical, supercritical, mixed, our flow regime. We want to do it subcritical. Then later we have to control the throat number. So now we can press compute. Looks good. Layer complete. Finished. Finished steady flow simulation. Computation task. Okay, perfect. We can close this window. We can close this window. And now here you see the different stuff. For example, the cross sections. We can click it. And now I see water inside my profiles, and can go through my profiles here. And I see water in every profile. Then there is view profiles and some other stuff where I can see, for example, this is more like a 3D view, so I see my profiles and the water level inside. Okay. So that was the first one, and then we meet again in the lecture.